Right, we're actually going to show two ways to do this. So this is going to be the first way.
Okay, sounds great.
But they both start off the same way. We need to factor the bottom.
That was step number 1 from slide 1, if you'll remember.
Notice that it's a smaller degree on top than on the bottom, so let's
We're good
factor.
to go.
So 1 multiplies to get negative 15, that adds to get negative 2.
Oh, you were asking me. So that's going to be 5 and 3. Negative 5 plus positive 3 gets me negative 2. Sorry.
Okay, so what we're going to do is we're going to use those as our denominators.
Right, I was trying to figure out why you weren't writing anything.
Because I was asking you. And then on top, since they're both linear, we're going to put A and B.
That's all. Now, that's all there is to that setup. Now, each factor has its own fraction.
Now, we're going to pretend like we're trying to get common denominators on this side.
Okay, that's a good plan.
The way you get common denominators, this is x minus 5, and we're trying to basically get back to this denominator. So what is it missing? It's missing x plus 3.
Right.
So we're going to multiply the top and the bottom by x plus 3.
Okay.
Right?
Yes.
And then this one needs an x minus 5. It needs
x plus 5, x minus 5, x minus 5. So that way we can add them up.
Right.
Because you can't add fractions unless the denominators match.
Right. Now that we have all the same denominators on both sides of the equal sign, we're going to drop out the denominators.
Because when you add fractions together, you don't mess with the denominators. You just add the numerators. So we need to make sure that the numerators are equal. So here we go, 5x minus 1. And
I just rewrote
there you
what
go.
our numerators.
That's all the numerators are. So there you go.
The first strategy we're going to use is we're going to pick values for x to plug in so that we can solve a and b.
So we're going to pick a really specific value of x, though.
Right.
With intention.
Yes, there are specific numbers that will be super helpful here because remember that 0 times anything is 0.
Yes. It's one of my favorite properties in math.
Yeah, so think about it. What value could I put right here for x that would make this parentheses be 0?
Pi.
No.
Oh. Negative 3. I was
negative
just
3,
kidding.
right?
I was
If you
close.
put a negative 3, negative 3 plus 3 is 0, so that'll cancel that out. So we're going to start off by plugging in a negative 3.
For all the x's. So if we say x equals negative 3, everywhere we see x, we put negative 3 in. Now what's really fun about this is one of our variables goes away.
Yes. I like to make a little sound effect because this is 0, so psh, psh, goes away.
Was that like lightsaber swords?
Kind of like a lightsaber exploding kind of a thing.
Yeah,
5 times negative 3 is negative 15.
Let me try now.
Minus 1. But we didn't actually mark anything out.
Oh, okay.
So negative 16. And then negative 3 plus a negative 5, that's negative 8. So that's
times
negative
b.
8b.
Now look, we went from this super complicated pre-calculus problem all the way down to a simple algebra 1 single step problem.
Divide by negative 8, 2 equals b.
There you go.
So we know the numerator of this fraction. Now I need to find the other one. So,
and it's really important, too, that 2 stays where the b is. And so an easy mistake to make is that you just go in and toss your numbers back into your problem.
Yeah, you don't want to put 2 on top of the first fraction.
Yeah.
The other number that's helpful here then now is what if we want to get rid of this one instead? What number would we put in for x?
5. Put a 5 in there.
Put it in.
Put in the 5.
So everywhere that x is, we're going to put in a 5.
Now, the b part goes away because 0 times anything is 0, which I've already said is one of my favorite properties in math.
You want to make the sound? Ready?
Yeah. Psh, psh. Was it as good as yours?
Pretty good.
Okay.
Pretty good. 5 times 5 is 25, minus 1 is 24. 5 plus 3 is 8, so that's 8a.
And again, difficult pre-calculus problem, single step algebra 1 problem. And boomo.
So to write the answer now, we come back to what this was, but we fill in a and b. So a is 3, that's over x minus 5. B is 2, which is over x plus 3. And that's our answer. Now, if you had written these in the opposite order, then you just would have gotten 2 over x plus 3 plus 3 over x minus 5, which is the same thing.
That's right. The 3 just needs to go over the x plus 5, the 2 over the other one. Doesn't matter what the...
x minus 5.
Right.
Yes.
Doesn't matter the order.
Right.
Right.